This question is from GATE 2016, Mechanical Engineering paper set 2, question number 37. The system shown in the figure consists of a block A of mass 5 kg connected to a spring through a massless rope, passing over pulley B of radius R and mass 20 kg. The spring constant K is 1500 Newton per meter. If there is no slipping of the rope over the pulley, the natural frequency of the system is dash radians per second. Now, when the mass applies a tension on the rope, the pulley will rotate. Let's assume that it rotates by an angle theta. If this is the original position of a point on the pulley, this will be its final position. It has rotated with angle theta. Both of these are R's. If the displacement is small, we can assume that this translational motion of the mass is y. This y distance can be expressed in terms of r and theta. Y will be equal to r into theta. Similarly, if spring is connected to the same rope, spring will also be tensed by the same amount. Let's assume it is y spring. This can also be written as r into theta itself. So ys will be equal to y. Now that we know the displacements of all the components, we can find out the energies in the component. So kinetic energy of the pulley plus kinetic energy of the mass will give us the total kinetic energy in the system. Because spring doesn't have any kinetic energy, it has potential energy that is stored in it. We can write total kinetic energy is equal to sum of these two. Now kinetic energy of the pulley can be written in terms of I and theta. We write it half of I being its mass moment of inertia. For a disk, pulley is equivalent to a disk. Mass moment of inertia is mr square by 2, where m is the mass of pulley, into omega square, angular displacement of the pulley, plus kinetic energy of the mass is simply given by half into mass of this given block into y dot, that is velocity of the mass in downward direction, whole square. Substituting all the given values, we get mass of the pulley is 20 kgs. So let's write 20 by 4 into r square. Omega square can be written as theta dot square plus half into mass of the block is 5 kgs into y dot can be written as r theta from here, and r theta dot will be nothing but r is a constant, theta dot. So let's write it r square theta dot square. If we take the r square theta dot square common, we get 5 plus 5 by 2, which will give us 15 r square theta dot square by 2. This is the total kinetic energy in the system. Now total potential energy will be equal to potential energy of the spring, which is equal to half into its stiffness small k into its displacement y whole square. Substituting y as r theta, we get k r square theta square by 2. Now let's find out the Lagrangian and then formulate the equation of motion. Let this be 1 and this be 2. We have Lagrangian is equal to total kinetic energy minus total potential energy, which gives 15 r square theta dot square by 2 minus k r square theta square by 2. Now if we have this as Lagrangian, equation of motion is given by d dt of dou L by dou theta dot minus dou L by dou theta equal to 0. By putting the value of L, we get first term will become 15 r square by 2 is a constant into 2 theta dot, and 2 gets cancelled. We get 15 r square theta dot. So d by dt of 15 r square theta dot minus dou L by dou theta is minus of 2 kr square by 2. 2 gets cancelled. We get kr square theta is equal to 0. Further, taking the time derivative of first term, we get here 15 r square theta double dot plus k is nothing but 1500 r square theta equal to 0. Taking r square common and dividing it with 0 on the other side, we get 15 theta double dot plus 1500 theta equal to 0. So we have the mass equivalent term to be 15 and stiffness equivalent term to be 1500. Let them be m star and k star. Natural frequency of this system omega n. It is not the angular velocity of the pulley, but it's the natural frequency of the system given by root over k star by m star, which is equal to root over 1500 by 15 gives us 100. Root over 100 is 10 radians per second. Let's go back and fill in the answer. Natural frequency of the system is 10 radians per second. To learn more about Lagrange's equation, you can refer to the NPTEL video, Lecture 5, Lagrange's equations, from the course Theoretical Mechanics. It's by Professor Charudat Kadolkar. He is from Department of Physics, IIT Guwahati. I hope the solution will help you clear your doubt. Thank you.